This is 2016-10b. A particle moves along a straight line in such a way that its acceleration is always directed towards a fixed point O on the line, and it's proportional to its displacement from that point. The displacement of the particle from 0 at time t is x, and the equation of motion is given. So that's where we're starting, with this equation. V is the velocity at time t, and omega is a constant. It says the particle starts from rest. Okay, so we have a velocity of 0 at a point P, and it is at a distance A from O. So distance, according to this equation, O is in terms of x. So its starting distance is A from starting position, or its starting position is A from the starting position O. So you've got to derive an expression for velocity in terms of A, omega and x. So we'll start with this equation. We want an expression for velocity. We'll separate the variables. V dv is equal to minus omega squared x dx. This will become v squared over 2 is equal to minus omega squared by x squared over 2. Remember, omega is a constant. Okay, plus c. I'll find the constant of integration here using the initial conditions. A velocity of 0 is equal to minus omega squared a squared over 2 plus c. So that means that c is omega squared a squared over 2. I'll put that back into this equation here. V squared over 2 is equal to minus omega squared by x squared over 2 plus omega squared by a squared over 2. I'll take out omega squared over 2. So, well, the 2's will cancel all the way across. So v squared is equal to minus omega squared x squared plus omega squared a squared. So I'll take out that omega squared. So v squared is equal to omega squared into a squared minus x squared when I rearrange it. And then velocity on its own is equal to omega by the square root of a squared minus x squared. Now in this particular case for this year, you could have given, because it's a squared, you're squaring, everything across is squared. This could be plus or minus. Okay. Now the second part says you've got to find x in terms of a, omega and w. So you're looking for an expression for x. If you start from the original equation of v dv dx is equal to minus omega squared x, this won't give us an expression for x in terms of a, omega and t. So there's no t. If I use this equation, it doesn't bring in a time. So therefore, I'm going to need an equation that will bring in a time. So if I use the one I have, this one here, and I've already put in for the constant of integration, so that's a general equation. If I use this one and change this v to, so for the second part, I'll change this v to dx dt. So this becomes dx dt is equal to the square root of omega by the square root of a squared minus x squared. Okay, I'll separate the variables, and this becomes dx over the square root of a squared minus x squared is equal to dt. I'll integrate both sides, of course. Now, this is a log tables formula. I'm just looking for the log table, I can't find it. Log tables formula, here it is. So when I'm integrating that one, the square root of a squared minus x squared, look what it's going to become. We're going to use this one here. So it's going to become a sine, arc sine x over a. So I'm using that one, that's in your log tables. So when you do that, you'll get arc sine x over a is equal to, oh, I've dropped an omega there, girl, sorry, equals omega times t plus c. Now let's put in our initial conditions. Remember that x was a at time 0, so x is equal to a when t is equal to 0. So this becomes arc sine of a over a, which is 1, is equal to, this will become 0. So the arc sine of 1, of course, isn't pi over 2. And remember, this section is all radians, so never degrees or only radians. So I'll put this back into the general equation then. So what do I have? This is my equation here. The arc sine of x over a is equal to omega t plus pi over 2. And it asked me to find x. So I'm just going to rearrange this here. And this is going to become x over a is equal to the sine of omega t